Have you ever wondered how chemists keep track of electrons in molecules?
Or how to show these electrons bonding?
Well, probably not, but we're going to show you anyway.
Let's learn about Lewis structures.
This is a Bohr model for chlorine. One important thing to notice about it is that there are 1, 2, 3, 4, 5, 6, 7 electrons in the outermost shell. So in order to draw a Bohr model, you first have to write the number of protons and neutrons in the middle. So that's what these two numbers are. Next, you have to count how many electrons the element has. Well, in a neutral atom of chlorine, there are going to be 17 electrons, just like there are 17 protons. So you have 2 in the first layer, and then you have 8 in the second, and 7 in the last. You have to draw a dot around the numbers in the middle for each electron there is, and then you have to know how many electrons to put in each shell. So the first shell is only going to have 2 electrons. That's this one right here. But then the next 2 shells can have up to 8 electrons. Now the outermost shell only has 7 electrons in this case because chlorine has 17 electrons total. So what about Lewis structures? They're going to be a lot like Bohr models, except for you just have to take the electrons on the outermost shell and you have to put those around the chemical symbol. So this is the Lewis structure for chlorine. If you look at it, there are 1, 2, 3, 4, 5, 6, 7. 7 electrons around chlorine. That's the same as the number of electrons on the outermost shell in the Bohr model. The important thing, again, is to remember to only use the valence, or outermost electrons in Lewis structures. Now let's look at the Lewis structure for carbon. Another way to count valence electrons is to count from the left to the right and skip these middle transition metals. So if you want to know how many valence electrons carbon has, you start at lithium. You count 1, 2, 3, 4. So carbon has 4 valence electrons, or electrons on the outermost shell. So to draw the Lewis structure, we would need the symbol for carbon in the middle and 4 dots around the outside to represent the 4 valence electrons that carbon has.
So as Patrick showed you earlier, the electrons that matter the most in bonding are the valence electrons, which are the ones that are shown on the Lewis structures. Now, this is very helpful when showing how ionic bonds and other bonds are formed. Now, if you take a look at an ionic bond, it's almost always between a metal and a non-metal atom. And now, the defining feature of an ionic bond is when one atom lends another atom an electron so that they both form a full octet. Take a look. So a good representation of an ionic bond is with magnets. Take a look at these magnets. So now imagine that this right here is an atom. The black inner magnets are like the nucleus, and then the outer silver magnets are like the valence electrons on a Lewis structure. Now, for the sake of this experiment, let's say you need 12 magnets to fulfill your outer valence shell. So clearly this is missing a magnet right here. But we also have another atom, and this has an extra electron. So if you stick them together, it's just like an ionic bond. This atom lent this atom an electron, and then they stuck together and formed a bond, fulfilling their outer valence shells. So now I'm going to show you how an ionic bond works. So we have sodium, chemical symbol Na, and we have chlorine, chemical symbol Cl. So sodium has 1 valence electron, as represented by its Lewis structure, and chlorine has 7, as also represented by its Lewis structure. Now, chlorine is going to tend to gain 1 electron, and sodium is going to tend to lose 1 electron in order to fill their full octet. So, if you look at this, sodium wants to give its 1 valence electron to chlorine, which would make a sodium 1 plus ion and a chlorine minus ion, because chlorine has an extra electron, so it has an extra negative charge, and sodium lost 1 electron, so it has an extra positive charge.
Covalent bonds are another interesting type of bond. It's another way that atoms try to achieve stability. Normally, atoms with smaller electronegativity differences, or that are of similar type, form these types of bonds. We can also draw the Lewis structure for water. As you know, water is H2O, meaning it consists of 2 hydrogen atoms and 1 oxygen atom. If we look at the periodic table, we find that oxygen has 6 valence electrons, 2 short of its full octet. And we find that each hydrogen has 1 valence electron. However, hydrogen is unique because it requires just 2 valence electrons to be stable. So oxygen can bond with 2 hydrogen atoms to gain its full octet. Hydrogen is unique because it needs just 2 valence electrons to be stable. So oxygen can bond with 2 hydrogen atoms to gain an extra 2 electrons to fill its octet.
Here's a little review for you guys. Lewis structures show the outermost electrons in an atom or molecule. In ionic bonds, one atom lends another atom an electron, and then they stick together. And in covalent bonds, atoms share electrons. The sharing of electrons in covalent bonds is shown by a dash in the Lewis structure of the molecule.